In this video, we're going to prove two very important and pretty simple and fundamental statements in combinatorics or set theory. The first one, though, is simply that 2 to the n is equal to the sum from r going from 0 to n of n choose r. So let's first write this out without using the sigma notation. What would this be equal to? We have to show 2 to the n is equal to, with r as a 0, we would get n choose 0, plus, when r is a 1, we would get n choose 1, plus n choose 2, plus, all the way to the end, I'll say n choose n minus 1, plus n choose n. So all I did there was just rewrite this, in a direct form rather than using the sigma notation. So we need to prove that 2 to the n is equal to that. And it's actually pretty easy by binomial theorem. That's binomial theorem. 2 to the n, first of all, is equal to 1 plus 1, right, to the n. That's simple. Well, we know how to use the binomial theorem on this. This is like a plus b raised to the n. The first term would be n choose 0, that's the coefficient, times 1 to the n times 1 to the 0. This n is the first one, and this is the second one. The next one would be n choose 1, 1 to the n minus 1 times 1 to the 1, plus, plus, n choose n minus 1, 1 to the 1 times 1 to the n minus 1, and the last term would be n choose n times 1 to the 0 times 1 to the n. And we're done. The binomial theorem, notice that everything except the binomial coefficients, this is just 1. 1 to any power is just 1. That's a 1, that's a 1, that's a 1, that's a 1. So we get n choose 0 plus n choose 1 plus plus n choose n minus 1 plus n choose n. And we're done. So knowing we could use this little trick, it made it very easy by using the binomial theorem. Now something that's related to this. Okay, so when you're given a set, what is this? When you're given a set A, what is that? That's the power set of A. It's the set of all subsets. So it would be, I can't list them out because I don't know what A is, but the first one would be the empty set. Then you'd have some other set and another set, and the last one would be A itself, which I'll just write like A. So you have the subset with 0 elements, you have the subset with all of the elements of A, and then all of these will be, subsets of size 1 up to the size, whatever this is, minus 1. So it's the power set, the set of all subsets of the set A. And I think we mentioned already that it's equal to 2 to the n. But notice, I'm just going to write one little sentence in is here. Notice, n choose r, r is at most n, r can't be greater than n. And let me do two things. Let's let n equal, what does that mean? The number of elements in A. Then, for the number r, somewhere between 0 and n inclusive, n choose r means how many ways can I take r elements out of the set A, out of the set of n elements? So that's the number of subsets. This is the number of subsets of size R in A, because A has n elements. How many ways can I choose R elements? Say R is 5. How many ways can I choose 5? How many different ways can I choose 5 elements? That's exactly, I'm choosing one subset every time I do that. So, in choose R is the number of subsets. So every subset of A has either 0 elements, it'd be the empty set, or 1 or 2 or 3, all the way up to the number of elements in the set A. So, by using the above, we could say that the number of elements is equal to the number of elements of size 0, which there would be 1, that would correspond to the empty set, plus the number of subsets that have 1, that would be n. If you have n elements in A, you can choose them one at a time in n different ways. How many subsets of size 2? That. Go all the way to the end to n choose n. And by this, 2 to the n, all of that is equal to 2 to the n. So here's the number of elements of all the different sizes going from 0 to n, and we just proved that that sum is equal to 2 to the n.